Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. Children, within the previous sessions we have concluded the theoretical aspects of our chapter work and energy. Today we are going to discuss some of the numericals based on those concepts work and energy. So be attentive throughout the sessions. Please be ready with your pen and notebook. Note down the questions and try to solve the numericals along with me. Notes are also uploaded along with this video lesson. So soon after this video lesson, you can copy down the notes. Still, you can try to solve the numericals along with me. Okay, so let's get started with today's session. So this is going to be our first question. A force of 7 Newton acts on an object. The displacement is say 8 meter in the direction of the force. Let us take it that the force acts on the object through the displacement. That means the force acts along the same direction of displacement. Then what is the work done in this case? Here force is given. Force is 7 Newton. Displacement is given. Displacement is 8 meter. Then work done. Equation to find out work done is force into displacement. That is 7 into 8, which is equal to 56. Unit of work is joule. So the answer is 56 joule. Okay. Now let's go to our next numerical. This is going to our second numerical. A pair of bullocks exerts a force of 140 Newton on a plow. So force is given, it is 140 Newton. The field being plowed is 15 meter long. So the distance or the displacement is 15 meter. How much work is done in plowing the length of the field? So again work done is force into displacement. So it will be equal to 140 into 15, and 140 into 15 is equal to 2100 joule. Okay, so this is the answer for this particular numerical. So you can pause the video for a while and you can note down the steps. Let's move on to our third numerical. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. So what will be its kinetic energy when its velocity is doubled? What will be its kinetic energy when its velocity is increased 3 times? So we need to find out the kinetic energy here. And we know in order to find out kinetic energy, this is the equation. Kinetic energy is half mv square. So if you want to find out kinetic energy, you must know mass of the object. But mass of the object is not given in the question. So first you are supposed to find out mass of the object from the first hint. What is the first hint? The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. So the kinetic energy of the object when its velocity is 5 meter per second is given. And what is that kinetic energy? It is 25 joule. So 25 joule is the kinetic energy, and that is equal to half m v square. Here what is the velocity at that time? When kinetic energy is 25 joule, velocity is 5 meter per second. So velocity v is 5 meter per second. So 5 square. Again we can write that is 25 equal to half into m into 5 square is 25. So just look at the LHS and RHS part. On the LHS and RHS part we have 25. So we can easily cancel them. Then we are left with 1 equal to half m. 1 equal to half into m. So from this what is m? From this m is equal to, take 2 to the side. Just cross multiply 2 into 1, that is 2. So mass is equal to 2 kilogram. So we have found out the mass. Next we can easily find out the kinetic energy when the velocity of the object is doubled and tripled. So velocity of the object initially is 5 meter per second. That is the initial velocity. When this velocity is doubled, velocity will be equal to 2 into 5, that is 10 meter per second, because doubled means just multiply it with 2. So 5 into 2 is 10. Then what will be the kinetic energy? Kinetic energy is half mv square. So here m is 2, we had already found that, and v is 10, so v square will be 10 square, and 10 square is 100. So here 2 and 2 will be cancelled, and we are left with the 10 square. 10 square is equal to 100 joule. So when the velocity is doubled, kinetic energy is equal to 100 joule. Now what happens when the velocity is increased 3 times? So when the velocity is increased 3 times, actual velocity is 5, and when it is increased to 3 times, just multiply it with 3. So 5 into 3 will be 15 meter per second. Then kinetic energy will be equal to half m is 2 into 15 square, v square, 15 square. So 2 and 2 will be cancelled, and we are left with 15 square. 15 square is 225 joule. So this is the kinetic energy when the velocity is tripled. That means when it is increased to 3 times. So from this question it is very clear, when the velocity is increased, kinetic energy is also increased. Initially when the velocity was 5, kinetic energy was 25 joule. When the velocity increased to 10, kinetic energy also increased to 100. When the velocity increased to 15, kinetic energy also increased to 225 joule. Okay, so you can pause the video and note down the steps. Children, next move on to the next numerical. Certain force acting on a 20 kg mass changes its velocity from 5 meter per second to 2 meter per second. Calculate the work done by the force. So here we cannot use the traditional way of calculating work done through the equation force into displacement, because force is not given in the question and displacement is also not given in the question. So we can use another way, that is the work energy theorem. We can apply work energy theorem in order to find out the work done in this case. So what is work energy theorem? Change in kinetic energy is equal to work done. Change in kinetic energy is final kinetic energy minus initial kinetic energy, that is kf minus ki, equal to work done. So here if you want to find out the work done, you need to find out the final kinetic energy, you need to find out the initial kinetic energy, and then just subtract it. So what will be the initial kinetic energy? Initial kinetic energy is half m into initial velocity square. Okay, so what is the initial velocity square? Initial velocity square is 5 square. And we know mass is 20 kg, so half into 20 into 25. 5 square is 25. So 2 tens are 20, and you will get 250 joule. Then similarly, what is final kinetic energy? Final kinetic energy is half into mass is again 20 into final velocity is 2. 2 square. 2 square is 4. So 2 tens are 20. 10 into 4, 40 joule. Okay. So initial kinetic energy is 250 joule and final is 40 joule. Then according to work energy theorem, work done is equal to final minus initial kinetic energy, that is 40 minus 250 joule. Okay. So 40 joule minus 250 joule. 40 minus 250 is 210 minus 210 joule. Negative sign shows that the work done is opposite to the direction of motion. That's it. Okay. So here the work done is minus 210 joule. Now we can discuss this question. An object of mass 40 kg is raised to a height of 5 meter above the ground. What is its potential energy? If the object is allowed to fall, find its kinetic energy when it is halfway down. So here, an object of mass 40 kg is raised to a height of 5 meter above the ground. So suppose this is the ground and an object is raised to a height of 5 meter above the ground. So what is its potential energy here? So here what is its potential energy? And we know that the potential energy equation is mgh. So what is mass? 40, g is 9.8, h is 5. And whenever you calculate, you will get the potential energy as 1960 joule. So this is the potential energy at that height. Now suppose the object is allowed to fall. So suppose this object is allowed to fall, and find its kinetic energy when it is halfway down. Halfway down means this is the path, and halfway down means exactly at the midpoint of the path. And at halfway down, the total energy of the object is equally shared by potential energy and kinetic energy. That means at halfway down, the total mechanical energy will be sum of kinetic energy and potential energy, and both kinetic and potential energy will be equal. Okay, both kinetic and potential energy will be equal. So here if you want to find out the kinetic energy, just find out the potential energy. That is enough, because at this point potential energy and kinetic energy will be same at halfway down. Okay, so if you want to find out kinetic energy at that point, just find out potential energy at that point. So here this point is at a height of 5 by 2, isn't it? This total height is 5. So at halfway down means this will be 5 by 2 and this will be 5 by 2. So now the object is at this point here. Okay, so what is the distance, or what is the height of this object from the ground? From the ground, the object is at a height of 5 by 2. So now what will be the potential energy? Potential energy is equal to mgh, and that is equal to 40 into 9.8 into what is h? Now the h is 5 by 2. So that will be equal to 960 joule. Okay, 960 joule. So at this point, that means at halfway down, potential energy is 960 joule. Since at that point potential energy is equal to kinetic energy also will be equal to 960 joule. Okay, so that's all about the numericals part. So children, with this I am concluding my session. We will discuss some more numericals of this chapter related to power and the electricity consumption in our next video lesson. Okay, so notes of the topic have been uploaded. Just go through it. There won't be any YouTube video based on this video lesson, as it is a numerical session. We will meet in the next session. Till then, take care all of you. Stay home, stay safe. Thank you.